Hello students, in this video we are discussing a gate numerical. A voice grade AWGN channel. AWGN means what? Additive white Gaussian noise. Generally noise will take, it is adding in additive manner, its color is white, it is having Gaussian PDF. We are not understanding that, so noise. So AWGN telephone channel has a bandwidth of the channel is given 4K and the two-side PSD is given 2.5 into 10 power minus 5 watt per H. If the information rate is 52 kbps, are you getting? Is to be transmitted over the channel with arbitrarily small error rate. Then what is the minimum bit energy EB in millijoule per bit is dash. This is one of the excellent problem comes from the information theory. Same question is also asked in the IS examination in that year as an objective question. So if you remember this, directly answer you can keep there. So some of the gate problems, some good questions are repeating in engineering service examination also. One of the excellent thing, what is the condition? Arbitrarily small error rate. For the small error rate, see the solution. For the small error rate, C value should be greater than or equal to R. Channel capacity always should be greater than the bit rate. Then there is no loss of information. What is the C formula? B into log base 2 1 plus S by N value should be greater than or equal to R. Then obviously, what is 1 plus S by N is greater than or equal to, obviously this is R by B and anti-log, but this is 2. So, 2 power R by B. So, finally, can I write S by N is greater than or equal to 2 power R by B minus 1. Are you getting my point? Now, what is S? Signal power. What is the relation between power as well as energy? Power is nothing but energy by time. Are you getting my point? So, this is energy by time. Time means bit duration by N greater than or equal to 2 power R by B minus 1. Then finally, what is energy greater than or equal to 2 power R by B minus 1 into N, and this is already in the denominator also. This is into TB. Or finally I can write E is greater than or equal to 2 power R by B minus 1 into N. N is called what? White noise power. What is the noise power value? Eta into B, N naught B. That is power spectral density. TB I can also write 1 by RB. Substitute all the values. So E value greater than or equal to 2 power 52K by 4K minus 1 into 2 side PSD given eta by 2. So what is eta value? 5 into 10 power minus 5. Bandwidth is 4K given and RB bit rate is given 52 kbps. Calculate that. Then E value greater than or equal to 31.508 millijoules will come. And E value greater than or equal to means what is the minimum value itself is 31.508. So you have to type here. Already he given millijoules. Excellent question from the, if there is no information loss, C should be greater than or equal to R. And you have to convert power into energy relation because he is asking the energy. If they are asking the power, everyone can make it. A slight modification hidden. An analog baseband signal band limited to 100 Hz is sampled at a Nyquist rate. The samples are quantized into 4 message symbols that occur independently with the probabilities given. P1 equal to P2 equal to 0.125 and the remaining is half of that. P1, P3. The information rate. Information rate means what we have to calculate, students? R value you have to calculate. R formula is H into small r. What is H? Entropy. This is symbol per second or sample per second also you can take. Now, this analog baseband signal is sampled at what rate? Nyquist rate. So Nyquist rate is nothing but 2 into FM. FM is 100. So 200 samples per second. This is the small r value. Are you getting my point or not? Now, calculate the H value. We know entropy formula. So get the each and every probability. Here P1 equal to P4 equal to 0.125. So 1 by 8. This is 1 by 8. This is 1 by 8. Remaining should be 6 by 8 because total probability is 1. 6 by 8. These two are. So half of that. So that is nothing but this is sorry P2 I think so. Yeah, P2. So P2 equal to P3 equal to 6 by 8. Half of means 3 by 8. You can add 1 by 8 plus 1 by 8 plus 3 by 8 plus 3 by 8 will be 1. Total probability 1. What is the entropy formula? H equal to summation I equal to 1 to 4 because 4 symbols are there. Probability into log of 1 by probability. Probability into log of 1 by probability. Substitute 1 by 8 log of 1 by base is 2, 8 plus 1 by 8 log 1 by 1 by 8. Next values. 3 by 8 into log 1 by 3 by 8. So 8 by 3 plus 3 by 8 into log of 8 by 3. All are base 2 only. If you calculate this value, you will get 1.811 bits per symbol. Substitute here 1.811 into R value. R is nothing but sample per second or symbol per second. 200. Then it will coming as a 362.2 information rate bit per second. Got my point? This is the solution for this problem. Simple information rate, H into R, H entropy and R value calculate. Clear? A binary communication system makes the use of the symbols 0 and 1. There are channel errors. Consider the following events. X0 is corresponding to 0 transmitted. Y0 is corresponding to 0 received. X1 corresponds to 1 transmitted. Y1 corresponds to 1 is received. The following probability is given. Probability of X0 given 1 by 2. Y0 by X0 3 by 4. Y0 by X1 1 by 2. The information in bits that you obtain while you learn which symbol has been received and while you know that 0 has been transmitted. And for this clear understanding, I will write a binary channel. Simple. This is the binary channel where 2 input symbols, 2 output symbols, namely 0 and 1, that is X0, X1. Output also 0 and 1, that is namely Y0 and Y1. And what is the probability of X0 given? Probability of X0 is 1 by 2. Obviously, X1 also 1 by 2 because total probability is 1. And Y0 by X0 given. Y0 by X0 3 by 4. Remaining will be obviously 1 by 4 because total is 1. Next, Y0 by X1. How much? 1 by 2. Obviously, this is another 1 by 2. Now he is saying that calculate the information in the received. Received is what? Y0 and Y1. You already know that X0 is transmitted. Are you getting my point or not? So, if 0 is transmitted, then what is the information in the received bits? Received bits are Y0 and Y1. Getting my point or not? So, follow. When X0 is transmitted, are you getting my point? What is the probability of receiving Y0 is 3 by 4. when x0 is transmitted, what is the probability of receiving y1 is already given. We calculated that is nothing but 1 by 4. Are you getting my point? So, what is the formula for information? Information I of x is nothing but 1 divided by r. No need of writing 1 by simple. Log of p of xi. X means x if you want you can take. And I written in the numerator means you have to write the minus. Because information the probabilities are inversely proportional. The more probability, lesser. Are you getting my point or not? Follow. Now, what is the probability of receiving y naught? The probability of receiving y naught is nothing but the transmitted one is x naught into y naught by x naught. And what is this value? 1 by 2. What about y naught by x naught? 3 by 4. So 3 by 8. One simple probability. Next, probability of y1. And he already told x naught transmitted only. Then what is the chance into p of y1 by x naught only? How much that is? 1 by 2. Y1 by x naught. Sorry, 1 by 4. Yeah, 1 second. Probability of x naught is 1 by 2. Okay. Y1 by x naught is 1 by 4. So 1 by 8. These are the two symbols and probability scale. Then what is the information? Information I equal in the two symbols. Log of 1 by probability na or minus you can write. 1 by means I reverse it. So 8 by 3 plus log of 8 by 1. Base is 2 only. If you calculate 0.811 bits you will get. Simple logic is asking information in y0 and y1 when you transmit x1. First calculate the probability of y0 when x0 is transmitted. Probability of y1 when x0 is transmitted, and I calculate the information. Information is nothing but log of 1 by p of x or minus log of p of x. Clear? A discrete memory-less source. DML means discrete memory-less source has an alphabets A1, A2, A3, A4 with probabilities, P means with probabilities 1 by 2, 1 by 4, 1 by 8, 1 by 8. Then the minimum required average code word length to represent this source for error-free reconstruction. This source for error-free reconstruction. What is asking? Minimum required average code length. We already knows that the minimum average code length L minimum is nothing but H. H is called what? Entropy. What is the entropy formula? Summation I equal to 1 to 4 P of xi into log 1 divided by P of xi. This is the formula for entropy. Are you getting my point or not? Where why I written 1 to 4? Because 4 symbols are there. Are you getting my point or not? Now see. Then L minimum, that is H equal to, substitute the first one, 1 by 2 into log of 1 by 1 by 2. Log 2 is 1 plus 1 by 4 into log 1 by 1 by 4. Log 4 base 2 is 2. Plus 1 by 8 into log 1 by 1 by 8. Log 8, so 3. Plus 1 by 8 into 3. Now follow. Calculate this value, you will get 3 by 4. Means 1.75 bits per symbol. So the minimum average code word length is nothing but 1.75. What is the code length? And average how many bits we are sending for each symbol? And what is the code length? The number of bits in the code is called code length. Everything clearly we discussed in our video classes. If you take the full length GATE course, then every topic full length videos will be there, and you will also get the solution copy. A digital communication system uses repetition code for channel coding and decoding. So each bit is represented as 3 times. For example, 0 is transmitted as 0, 0, 0. 1 is transmitted as 1, 1, 1. It is assumed that the source puts out the symbols independently with the equal probability. Decoder operates as follows. How the decoder is operating? In a block of 3 received bits, if the number of zeros are exceeds the number of ones, it is treating as 1. Sorry, it is treating as 0. If number of ones are more than number of zeros, it is treating as 1. Are you getting my point? He is sending a block of 3 zeros. In 3 zeros, the number of zeros are more than number of ones, it is treating as 0. In the block of triple ones, if number of ones are greater than number of zeros, it is treating as 1. Now, with the crossover probability of 0.1 in a binary symmetric channel, then what is the average probability of error we need to calculate? If you see here, in a block of how many bits we are sending? 3 bits. 3 is a finite or infinite? Finite. Whenever finite is there, simply you can apply the binary or binomial theorem you can apply. Are you getting my point? So, what is the thing here? For example, if I am sending 1, how 1 is transmitted? 1, 1, 1. This is come to the receiver end. When receiver will treat as 1, if number of ones are greater than number of zeros. When receiver will treat as 0, whenever number of zeros are greater than number of ones. And he is asking about the average probability of error. What is asking? Probability of error. Follow. Now we are asking error. When error will be there? If I transmit 1, it is receiving as 0. Now it will be error. Are you getting my point or not? Now, when it will treat as a 0? When number of zeros are either 2 or number of zeros are 3. Into error probability, how much is given? 0.1 whole square, 1 minus p. 1 minus 0.1, 3 minus 2, 1. 3c3, 0.1 whole square into 1 minus p whole power 3 minus 3. 0 na? Whole power 0 means 1. Calculate. 3c2 value 3. 0.1 whole square 0.01. This is 0.9 plus 3c3 1 into 0.01. Multiply 0.03 into 9, 0.027. So 0.027 plus 0.01. Then it will be 0.028. It is a blank type of question and you have to type 0.028. Simple problem from binomial theorem. Here the number of bits are block is 3. So finite. If it is more number is there, go for the Poisson's distribution. Here finite, binomial distribution. Clear? See the next problem. Consider a discrete memoryless source with alphabets S0, S1, S2 and so on he given. With the respective properties given, is asking the entropy. We know that. What is the formula for entropy? Entropy of the source H of S you can call 1 by probability into log of 1 by probability. Like all symbols you have to take. That is summation. So first one probability 1 by 2 into log of 1 by 1 by 2 log 2. 1 by 4 into log of 1 by 1 by 4 log 4. 1 by 8 into log of 1 by 1 by 8 log 8 plus and so on. If this model we already done 1 by 2 into 1 plus 1 by 4 into 2 plus 1 by 8 into 3 like and so on. Take 1 by 2 common. 1 plus 2 into 1 by 2. Already 1 by 2 I taken common. Plus 3 into actually 2 power 3 but 1 by 2 already taken. So 2 plus and so on. This is nothing but 1 minus x whole power minus 2 formula as I already said. So 1 minus x means here 1 by 2 whole power minus 2. 1 minus 1 by 2, 1 by 2. To avoid the negative sign, 2. 2 square, 4. 4 by 2, 2. is the answer. Entropy na bits per symbol. Clear? Yeah. Consider a binary memoryless channel characterized by the transition probability diagram shown below. This is the channel diagram they given. The channel is either lossless or deterministic or useless or noiseless. This is sorry. Last option is noiseless. These are the four options they given. Now follow. First, can I write the channel matrix? What is the channel matrix? H of y by x is nothing but y naught by x naught 0.25, y naught by x1 0.75, 0.25, and this is given 0.75. This is the channel matrix. Either curly bracket or square bracket, anyone can use. Now, in these type of problems, try to understand, of course, whatever is the answer here, try to understand when we can call lossless, when deterministic, when noiseless. The given channels are said to be lossless channel whenever it is having only one element in each column. The channel is said to be lossless whenever it is having only one element in each column. For example, if I write for lossless channel, how it will be? Suppose if I write the channel matrix for that, might be I can write like this: 1 0 0 0 0 1 2 by 3 0 0 0 1. Can I write like this? Because you can observe only one element in the each column, then it is said that lossless. What is the meaning of that? Lossless meaning is if you send the symbol, definitely it come to the output side, but it might be received as anyone because of adding noise, but it never be lost in the transmission. Next one is deterministic, means we can clearly determine. What you can determine? Follow. If I write the channel matrix, you will get the clarity. Y by x for this one is, it is having only one element in each row. So just like 1 0 0 0 1 0 1 0 0, like 0 0 1, like you can write. It is having only one element in each row. The meaning is, this is for example x0, x1, x2 symbols are there, output side also y0, y1, y2, y4, like symbols if you take. What is the meaning of deterministic is, if you send x0 symbol, it is receiving whether y0 or y1 or y2 exactly determined, but previous case not. Now, last one is noiseless. When you can say given channel is noiseless, whenever the given channel is lossless and deterministic. Lossless and deterministic, we can call it is a noiseless. Just like a identity matrix, you can remember. Now, compare this channel matrix with any of them. It's not comparable to any of them. It's not equal to any of them. Not equal to any of them means it's a useless channel. It's a simple problem. Clear? So such type of questions are coming. First, understand for all options also. Of course, this question is useless. The answer doesn't have the meaning there. But the thing is, try to understand about the remaining also. Then you can improve your knowledge. Clear? Which of the following graphs shows Shannon capacity in bits of a memoryless BSC channel with a crossover probability is given P? Means he is asking that the graph between channel capacity to probability. What is the formula for channel capacity? The formula for channel capacity is C equal to 1 plus P into log P base is 2 plus 1 minus P into log 1 minus P base is 2. Of course, we already know C is nothing but 1 minus entropy of the channel. And what is channel capacity? You can also write maximum value of mutual information. I max value is nothing but C value. So he is asking the graph between probability to C. Or in the previous examination, some university level examinations is also asking for a BSc channel entropy to probability. Almost both will come similar manner only. Slight difference will be there. Follow. First, let's solve this problem. And here probability we already know lies between 0 to 1. If you take probability value 0, this term 0, 1, log 1 is 0. So 0 plus 0, 0. 0 plus 1 is 1. So whenever probability is 0, C value 1. Then see, I can avoid two options. What are the two? B option, D option, I can avoid. Because at probability equal to 0, its value should be maximum. Second. Let's go for the next end will be, are you getting here? Let's take p value 1 by 2 midway. If you take p value 1 by 2, this is 1 by 2 and 2 you can write, but a minus will come. Minus 1 by 2, here also minus 1 by 2, 1 minus 1, 0. So at midway, it is 0. Okay, both are valid. Next, at extreme end, if you calculate p value 1, then this is 0, this is 0, 1. So this is also 1. But the thing is, whether it is a straight line decreasing or parabolic wise slowly decreasing. If you take the logarithmic graph, it never decreases as a straight line. So answer will be sorry, option C. Simple logic. Substituting the p value from 0 to 1. Next, entropy versus probability. Another problem. What is the entropy value here? Minus of this is nothing but entropy only. So entropy is nothing but minus of p log p base 2 plus 1 minus p log 1 minus p base 2. Are you getting my point or not? See. Take probability value 0. This is 0 log 1 0. So it is starting from 0. Take probability value 1. Also 0. Take probability value 1 by 2. Whenever equal probability, entropy will be maximum. What is the maximum? Log 2 base 2. Because binary means two symbols only. Maximum value log n base 2 or log m base 2. If m symbols are there, maximum entropy is log m base 2. Plenty of problems we done in the previous problems based on the maximum entropy. So it will be this type of shape we will get. Capacity versus probability, this one. Entropy versus probability, this one. Getting my point or not? Let x1, x2 be a independent random variables. x1 has mean 0, variance 1. x2 has mean 1, variance 4. Mutual information between x1 and x2 is asking. And the condition given, they are independent. What is the mutual information? What is the definition for mutual information? Mutual information is nothing but the mutual dependence between the both. The mutual dependence between the both is called mutual information. Now here if you observe, or if you are not understanding, I can tell you when in another manner. Mutual information is nothing but knowing the information about one random variable by observing the other random, or by observing the other variable, is nothing but mutual information. So mutual dependence. But what is the condition given? Both are independent. Independent means there is no dependency. If there is no dependency, mutual information is 0. What is the mutual information? Dependency between the both, but the given is independent. So the mutual information will be 0. Very simple question. A binary channel code in which each code word has a fixed length of how much? 5. The Hamming distance between any two pair of distant code words in this code is at least 2. The maximum number of code words such a code can contain. The maximum number of code words such a code can contain. There is a one condition we have according to the Plotkin bound. Like in the class we also discussed what is a Hamming bound, Plotkin bound. According to this, D minimum value less than or equal to m into 2 power k minus 1 by 2 power k minus 1. Feel the difference. This is minus 1 in the numerator, the power. Here not. What is the code word length here given? It's a fixed of 5. What is the D minimum value given? At least 2. Means Hamming distance is at least 2 means minimum value is 2. That minimum Hamming distance is called D minimum is 2 given. Now we need to calculate. If we calculate K, then 2 power K is nothing but maximum number of code words. What is the K? K is nothing but number of data bits. N is nothing but number of bits in the code. Number of bits, data bits. What is P? Parity bits, N minus K. Are you getting my point or not? Now see. This value substitute can I write? This is less than or equal to, or I can say 2 power k minus 1 by 2 power k minus 1 greater than or equal to 5 by 2 I can say. Are you getting my point? For example here, let's say trial and error base. If you take trial and error base, if you take for example k value 1, 1 minus 1, 0, 2 power 0 means 1, so it's not satisfied. Take 2 value 3, 4 like that. So if you take some, after some particular value, for example, if you take k value 10, definitely satisfied. 11, 12, any value satisfied. But we already know n is greater than k. N already given 5. So k value should be less than 5. Like make trial and error base, you will get a maximum value for k is 4. Now, the maximum number of code words is nothing but 2 power k, 2 power 4. So 16 possibilities are there. 16 not possible. 16 maximum code words will be there. Clear? A linear Hamming code is used to map 4-bit messages to 7-bit code words. Like if the message 0001 is mapped as 40111 and the message 0011 is mapped as 11001110. Then the message 0010 is mapped to. If you see the question, if you know it, it is a very silly question. When we are saying this point, also student will feel whether this question will comes in the exam. But in 19 they given. So here no innovative thing, simple. Any code is said to be linear. Addition of 2 codes will bring the new one. Addition means modulo 2 operation, that is XOR operation. So make the XOR operation between the both. What is the XOR operation? If both symbols are different, output is 1. Both symbols are same, output is 0. Make the XOR between the both. First one 0, different, so 1. 0, 1, different, so 1. Next 0, 0, same, 0. Next 0, 0, same. Next 1, 1, same, 0. Next 1, 1, same, 0. Next 1, 0, different, so 1. So 1, 0, sorry, 1, 1, 4 zeros, 1. 1, 1, 4 zeros, 1. Option B is correct. Simple XOR between the both. XOR operation, both are same. Output is 0. Different, output is 1. Clear? See the next problem. A binary random variable x takes the values plus 2 or minus 2. Two possibilities. The probability of plus 2 is alpha. The value of alpha for which entropy of x is maximum is dash. When entropy is maximum, students, whenever all symbols are having equal probability of occurrence, 2 symbols are having both are equal probability, then what is the alpha value? 0.5. So type 0.5 in the option. It is a 1 mark question in GATE 2020. A simple logic. By knowing that, we already know entropy is maximum when all symbols are having equal probability of occurrence. 2 symbols, equal probability, 0.5. Clear? Yeah.